You've listened to the song now, and I'm going to quickly talk you through what you need to know from there. So, besides one use for each of these waves, what I hope you saw is that the size of the wave, so the wavelength of the wave, gets smaller and smaller and smaller as we get to the more dangerous waves. So, if you think about it, it must make sense because the the smaller the wavelength is, the bigger the frequency must be. Because if the speed is all constant, then I'm going to write it down in an equation now. If the speed is constant, as the wavelength goes up, the frequency must go down. So those two are inversely proportional to each other. The other thing I wanted you to see is they're looking at the here at temperature, but temperature is also an indication of the energy that something has. And you can see here, as the frequency goes up, the energy of the particles, of the, not the particles, I mustn't call it that yet, the frequency, as the frequency goes up, the energy goes up. And those are the two equations that we're now going to look at in a lot of detail. And you're going to do a little worksheet just practicing using these two equations. So what they are, I'm just going to minimize this so I can quickly write it for you. You have this on your information sheet again. Let me give you everything. The first thing we already spoke about is that you know that the speed of the wave that we're now going to call c is equal to f lambda. And that's what I said originally. So if you look at this, because this is a constant, you can say that the frequency is equal to a constant over the wavelength. So that means the frequency is directly proportional to 1 over the wavelength. So this means that they are inversely proportional to each other. So as the wavelength goes up, the frequency goes down and vice versa. This is the first relationship you need to see from the electromagnetic spectrum. So the next relationship is that the energy is directly proportional to the frequency. So the higher the frequency, the higher the energy. And there was a very important man called Planck that went and looked at the relationship between the energy and the frequency. So if you take a wave and you plot a graph of the energy as the frequency goes up, you will see that you get a straight line graph. Now, you battle with this sometimes in the exams, but you actually all know that this is y and this is x. So y is directly proportional to x, so that means we can say y is equal to mx plus c, but there's no y-intercept here. So we can say that E is equal to F. So we can change the direct proportion into an equal sign if we add the constant, which is the gradient. And what Planck did, he did a lot of experiments and determined this constant that was then named after him. This equation you also get on your information sheet. So the equation at the top, C equals F lambda, and the equation at the bottom, E equals HF, you get on your information sheet. But now if you combine these two equations, and they even give you this one, you can see that the frequency is equal to C over lambda. So I can put that in here and I can then say that this is HC over lambda. You get both these equations for energy. So if they give you frequency, you're going to use HF to get the energy. If they give you the wavelength, then you're going to use HC over lambda. Please remember that C and H are both constants. Please now go and take your information sheet and find them on your information sheet. You'll see H is there as Planck's constant, and it's 6.6 times 10 to the minus 34. C is the speed of light, and it is 3 times 10 to the 8. Familiarize you with the position of these things on your information sheet. Now, energy, if you remember correctly, energy is normally measured in joules. So we are still going to measure energy in joules, but because later on you are going to look at different phenomenon, and I don't want to give it away yet, but we'll get there in the next lesson. You're going to look at energy in another unit. And you will see that energy can also be given to you as electron volts. Again, go to your information sheet and go and look for this because it's there. So to convert from joules into electron volts, you're going to divide by 1.6 times 10 to the minus 19. And if they give you electron volts and you want your energy in joules, then you're going to times by 1.6 times 10 to the minus 19. So the little worksheet, there's only 5 questions that I am giving you for the rest of this lesson. The answers are there, so please go and do it. And if you don't get to the right answer, please ask your teacher to help you because it's simple calculations and you should be able to go through them quite quickly. Now for our next lesson, which is super important, we are now going to look at, is light actually a wave or is light a particle? And I'm sure you've heard about this already. So I want you to go and think a bit for the next lesson. What do you believe? Is light a wave